completing LeetCode 54 today spiral matrix. And the prompt says, given an m by n matrix, return all elements of the matrix in spiral order. So what this means is, given a array of arrays of numbers, we want to basically traverse this matrix in a fashion as basically going all the way to the right, all the way down, all the way to the left, up, and then repeating that process over again. So when I first solved this problem, the first thing that came to my mind was, okay, if we're going to be traversing a matrix, then I'm going to need to have some sort of data structure that's going to save the positions that we've already visited. So indeed, we are going to have to use maybe a set to do this, and we're going to store the positions, the row and the column of the positions that we've already visited. And then what we're going to do is we're going to need to have some type of loop that's going to allow us to loop through all of the potential spirals that are going to be in this matrix, or even this matrix, meaning the matrix can be, it's not necessarily a square matrix. As you can see, this one is 4 by 3. And what's going to happen is we want to have a loop that will allow us to traverse all of the spirals within this and save it to this output array. So let's start coding. Because I think it would be best, I'm going to kind of set initial variables in a class rather than in the function itself, because we're going to be creating multiple methods that are going to be taking place on this matrix. So I'm going to set maybe an init function, and I'm just going to have, well, we need to have first a results array. We'll initialize that to a Python list. We're going to need to have a visited set. We're going to have the matrix itself, and that's good for now. If anything else comes up, we'll put it in there. So what we're going to need to do is, first I want to make sure that this matrix is going to actually have some elements in it. So I'm going to say if the length of the matrix is equal to 0, or the length of the matrix at index 0 is equal to 0, we're just going to return an empty list. And basically what this is doing is it's saying the length of the matrix. So that means if there are 0 rows right here, and if there are 0 columns, then we want to return as an empty list. And what this is going to do is it's going to ensure that moving forward, we know that we have, if we're accessing at least the matrix at the 0th index, it'll exist. So I'm going to put up here, I'm going to do a num rows variable and a num columns variable, because this is going to be useful. I'm going to set that here. Self.num rows is equal to the length of the matrix, and then self.num columns is equal to the length of the matrix at 0th index. And I'll stop here for a minute to explain this. So given if we were to have a matrix such as we have here, we can imagine it like this. So these would be our rows, and then this would be a column. So for instance, this would be column, this first set of numbers would be our column 0, column 1, column 2. So if we're going to be asking for what's the length of the matrix, then we're asking for what's the length of all of these, and that would in this case be 3. So the length of our matrix, the number of rows that we'll have will be 3, and then the number of columns is obviously, how many of these exist, and we know that it's an n by n matrix. It's going to be the same for all of them, so we'll just get the length of the first, because we know that it at least exists because of this. And now we're going to move forward Now we're going to need to have some type of positional current position function or current position variable. So I'm going to call something called current position. I'm just going to set it to a tuple. And the reason why I'm using a tuple is because we're going to be inserting these positions into our visited set. Tuples are hashable, so they can be put into a visited set. And also I think it looks a little bit cleaner than other things. So basically starting at 0, 0 is going to be right up here, in the 1 is going to be right here. This would be our 0, 0 position. And what we're going to do is we want to continue. I want to think to myself, how am I going to iterate through all of these, and when do I need to stop? I'm going to use a while loop, but what is my condition going to be? Well, we know we're going to traverse through at least every single element within this matrix, and we're going, for each of those elements, we're going to be adding the position of that element to our visited set. So what I'm going to do here is I think I'm going to say that the length of our, we're going to continue this while the length of our visited set is less than the total number of items in our matrix, which would be represented by multiplying the amount of rows by the amount of columns. Okay, hope that makes sense. And what we're going to do here is we're going to mark this position. So we're now at position 0, 0. What I want to do is I want to mark this position. So I'm going to create a new function called mark position. I'm going to pass the current position, and we're going to write this function later. And what I want to do after I mark this position is, well, you know what, let's write it down. So we're going to define this on our class, call it mark position. In Python, we pass self as the first parameter, and the second parameter is our parameters, so position, which is a tuple. And what we're looking for is we're looking to say we want to add this position right here to our visited set. So self.visited.add position. We also want to add the value of this position to our results array, because we're going to want to basically add, now that we're visiting this position, we want to add that to our results array, which I have not created yet. Oh, yes I have, sorry. Results list. So basically what we want to do is we're going to do self.resultList.append, and we want to probably create another, well, you know what, we don't even need to do that. We can just do, we want the self.matrix at position 0 and position 1. I hope that makes sense. Position 0 is basically the first item in our position tuple, and then position 1 is the second, and this will be representative as rows, as row and column. And I just realized that I never set my matrix, so what I'm going to do is right here, I'm going to do self.matrix is equal to matrix. And okay, great. If we wanted to make this a little bit prettier, which I think I will do, I'm going to create a function called value at position, and it's going to receive the position. And what I'm going to do is I'm going to break this position using Python. I'm going to break it into a row and a column. What this will do is it'll take the first element in this position tuple, put it into row, second element into column. We're going to return self.matrix. I have a hard time typing matrix at row and then column. I think this looks a little bit more readable, and that's what we're kind of looking for, especially in maybe an interview. So I'm going to do self.value at position. I'm going to pass the position. Okay, boom. So now what's happening is we are at the 1. We're going to mark this position by saying self.visited, add the position to our visited set, and then we want to add the value at position 0, 0. So value at position, and let's confirm that that's what it's going to do. It's going to say the row column position, self.matrix row column, the value of that. We're going to append it to our result list. Okay, I think this is going to work. Now what do we want to do? Well, next what we want to do is, the first time I tried this, I realized this picture is a little bit deceiving. So it's saying basically there's arrows between the nodes in this matrix. So it's saying 1 go to 2, 2 go to 3. Really, as an overall view, what we want to do is go all the way to the right, all the way down, while adding all of these nodes that we're visiting to our results array, our results list up here. And then we want to go all the way to the left, all the way up, and then we want to do the same thing again for, you know, the inner spirals. Okay, so we're going to accomplish this with 4 while loops within our main while loop. And this is going to be okay because for each node that we visit, we're going to be adding that position to our visited set. So this will never be invalid, because even though we're going to be doing multiple while loops within our main while loop, this is still going to be the case. You know, if ever we get to the point that that the length of our visited set is equal to or greater than our items that are in the matrix, we're going to break, okay? And this will make more sense in a second. So I want to move all the way to the right, and then we're going to give it some space. We're going to say we're going to go down, and we're going to go left, and then we're going to go up. And then lastly, this is something that I had to be careful for, which I did not get correct the first time. And this is why I think it's important when I do these interviews, when I do these problems, especially in technical interviews, because you can't execute your code in technical interviews, is as you're testing your code, to make sure to pay attention to the beginning of the test, and specifically don't get lazy and say, okay, this is going to work for the whole thing. It's beginning, put a lot of emphasis on the beginning of the test, you know, go through the test, and then also for the end of the test, because you want to test for the beginning of the input array, the end of the input array, special cases, edge cases, that type of thing. We want to basically shift current position over by 1 column to the right. And the reason why we want to do that is, let's say we traverse this from 1 to 4, 4 to 12, 12 to 9, 9 to 5, and that would be the end of this while loop. Now, on our next position, we're going to need to start at the 6, and that's what this is going to do right here. So you'll see this in a minute, and this is going to be pretty easy to write. So follow along here. We're going to do while. We're going to define a new function. So while self dot is valid position, and what we're going to do is we're going to pass it a position tuple, and we're going to say whatever the current position. Now the current position at index 0 is the row, remember, and the current position at index 1 is the column. And since we're moving to the right, that means we want to add 1 to our column. So basically, if we wanted to get to the 2, it wouldn't be 0, 0, it would be 0, 1. If we wanted to get to the 3, it wouldn't be 0, 0 or 0, 1, it would be 0, 2. Likewise for the 4 in this matrix, if we wanted to access this element, this 4, it would be 0, 3, right? Because it's the row 0, column 3, because we start with zeros. And basically, I want to add 1 to my column right here. And This should make sense because I want to say basically I want to continue going to the right while the next element that I could potentially visit is valid. Okay, and what is valid? Let's define that here. All right, let's define that is valid position self, and then we're going to pass a position. Okay, and we're going to break this up. Row column is equal to position. All right, so what's a valid position? So let's say we go all the way to the right to the 4, go from 4 all the way down to the 12, 12 to the 5. Do we go all the way up to the 1? No. Why do we stop at the 5? We stop at the 5 because the 1 has already been visited. So basically what we're doing is starting at the 1 right here, starting at the 1, we're saying, while this next element that I want to visit, that's to the right, which is basically the same row but the column plus 1, which is what we have here, while that is a valid position, meaning while we can move to that position next, we want to keep doing that. And if we get to this 4 right here, the next valid position would be somewhere over in this space, which is outside of our matrix. We're going to need to check for that in our isValid matrix function right here. So we have 2 cases that we're going to look for. So we're going to say if position is in self.visited, we're going to return false, because if it's been visited, then it is not a valid position that we can move to next. Then we're going to say we're going to return, or rather it makes more sense if we say this. We say if position, or if our row is greater than self.numRows, right? Greater than or equal to self.numRows, because we're going to start from 0. Actually, to make this a little bit easier, what we're going to do is we're going to return. And we're going to say, we're going to return that our row that this current position's row, it's less than numRows, and the row is greater than or equal to 0. That means that the row isn't all the way over here in the boondocks, and it's not all the way over here off the screen in the boonies. And we're going to do the same thing for the column. And we're going to say, and the column is less than self.numCols, and the column is greater than or equal to 0, because it can be 0, but just can't be less than 0. And the reason why this is not less than or equal to is because, remember, arrays start with 0, so if column was 4 in this case, it would be 0, 1, 2, 3, 4, which would give an array out of bounds exception. So we're going to return this, and this is going to say basically, as long as the row is less than the amount of number rows, and the row is greater than or equal to 0, and the column is less than the amount of number columns, and the column is greater than 0, that means this item is somewhere within our matrix, and it has not been visited. Okay, so while isValid position, current position, this is the row, this is the column, and we're adding 1 so that we can shift to the right. We want to do this. We want to mark this new position. First, we're going to set the current position equal to this new position, because we do want to keep track of the current position. And then basically we want to do self.markPosition at that position. Okay, and we're going to copy this. This goes all the way to the right. Now we want to do this for down. Now, how would down work? Well, let's say we're at the 3 right here, or let's say we're at the 4 right here, we want to go down. Well, we would stay in the same column, but the row that we want to access would be shifted for 1. So instead of accessing row 0, we'd want to access row 1. And so what we'd want to do is we want to add 1 to our row part of the position and keep the column the same. add 1 here as well. Okay, that looks good. And then we're going to copy this for the left as well. To move to the left, we want to keep the row the same. So if we're at 12, we want to go to 11. We're going to keep the row the same. But we want to subtract the column at least by 1. That will move us to the left. So we're going to subtract 1, subtract 1. And that looks good. And now we want to move up. And up is going to be same. We're going to stay in the same column. So the column doesn't need to change. However, we need to subtract 1 from our row. Subtract 1 from our row. And lastly, we want to shift the current position over by the column once. So we want to say the current position is equal to the current position at the current row, shifted over by 1 column, because let's say we go to the 4, down to the 12, to the 9, to the 5. That means we would be right here. Like after we get to the 5, we've gone up as far as we can, meaning we're at the 9, we go to the 5. Is the 1 a valid position? No, it's not valid because we've already visited 1. So that means we're going to break out of this while loop just by nature of that it is not a valid position at the 1. And next we're going to need to shift over by 1. And why would we need to do that? Well, let's assume that we didn't have this this piece of code right here. Well, we would go back up to our while loop, we'd be at 5, and we would mark 5 again, okay? And if we mark 5 again, we're going to try to move all the way to the right. And I guess in theory that would work. However, I noticed that it did not work. And I guess we could try it. You know, this is not perfect, so we could try it and see what that would give us. Let's leave it there for now, and let's return self.resultList. And then we'll kind of test it over here. So we have a result list, we have visited, we have matrix 1, row columns, num rows, num columns, and we're saying if the length of the matrix is equal to 0, or the length of the matrix at the 0th index is equal to 0, we want to return an empty list. The matrix self.matrix is equal to matrix, num rows is equal to the length of the matrix, which would be these going down in a vertical fashion, and then the column would be these numbers here. Our current position is equal to 0, 0, and then while the length of our visited is less than the total numbers in the total columns, num calls. I'm sure you saw that. We want to mark this position, and marking a position will add the position to our visited set, and it will append the value of that position to our result set. So that looks good so far. And then what we want to do is now we're at the 1, and we marked the 1. So now we're saying while staying at the current row, adding 1 to the column. While we're doing that, the current position is the current position, adding 1 to the column. We're going to mark that position, and we're going to do it again. Mark that position, and then we're going to go here, say no, we can't go there, so we're going to go down here. And how we're going to do that is we're going to say we're going to stay at the current column of the current position by nature of leaving this the same, but we're going to add 1 to the row, so we're going to go down 1, down 1, and now we're going to go to this left while loop. And on the left, we're going to say stay in the same row by nature of this staying the same and this staying the same, and we're going to subtract 1 from the column. So we're going to go 8, mark that position, 7, mark that position, and then we'll go here because there's nothing to the left that would be out of bounds. And then we're going to say at this current column, so keeping the column the same, we're going to subtract 1 from the row, which would happen here. And so we're going to go up, and then we're going to try to go up again, but the 1 has already been visited, so we're going to stay here. And now if this code was not here, so if this was not here, we would be, our current position would be at 1, 0, and we would go to this one. You know, honestly, I think that this would work even without this right here, but we'll see what LeetCode has to say. So that actually gives me a wrong answer, and what it says is I was expecting a 1, 2, 3, 6, 9, 8, 7, 4, 4, 5. So we missed something along the way here. As a matter of fact, I added the 4 a second time. Isn't that interesting? So that's what was breaking it. So when I marked, so let's say we didn't have this function piece right here. When we go all the way around and we end up at the 4, and then we get back up here and we mark the 4 again, then that's going to create a duplicate, just like we saw in the console right here. We have an additional 4. So basically it went 1. If you're following along here, it goes 1, 2, 3, 6, 9, 8, 7, 4, and then right here is where it would stop, and then we go back up to the top and we're going to mark that position again, so it's going to remark the 4. I hope you guys can see that. And you know, I'm showing you guys this because these are the type of problems that you'll run into as you're and I run into as I'm programming, and it's helpful to see that somebody else struggles with these type of problems. But I solved this by recognizing that, oh, okay, I need to start at the 5 for the next round. And this is why, for me, I've learned that it's important that I am being due diligent at the start of my testing, you know, because I can't run this on a coding interview. Being due diligent at the start, and then being due diligent at the end. So basically, if I was to test this, I'd be like, okay, so while I'll go up 4, and then 1 cannot be there, so I would be at the 4. And then I would go up to the top and I would mark the 4, and what that would do is I would add the 4 to our result array. But the 4 would already be there. Okay, so I need to actually shift my pointer over once so that I can start at the inner spiral, at the inner array. Okay, so then I would just add this line here. I hope that makes sense, guys. Let's run this now to see if it does work, and it does. And let's see, submit. We'll submit this, and it is somewhat fast and succeeds. All right, thanks for watching.